Hey, hi guys. This is your Rohit. So today we'll talk about the BFS in C programming. What is a BFS? BFS is the breadth first search. So let us see what is the program and what's and all that. So let me search. So our topic is this breadth first search. What is a BFS? Breadth first search is an algorithm used to search a tree or graph. BFS search starts from the root node, then transverses into the next level of tree or graph. So if item found it stops, otherwise it continues with other nodes. In the same way, the level before moving on to the next level, the algorithm can also be used for just a tree or graph or transversal without actually searching for a value. So mention this graph, the item which is given before. So the BFS search is also so named because it expands the frontier between discovered and undiscovered vertices uniformly across the breadth of the frontier. So the algorithm uses a key queue to keep track of which vertices to visit next. It starts by adding the root vertex to the queue and then repeatedly removes vertices from the front of the queue, adds their neighbors to the back of the queue, and marks them as visited. So this process continues until the queue is empty, indicating that all reachable vertices have been visited. So consider the graph which is given beside. I'll give you the next one. So this is the graph which is given beside. The all the things which is given, you can see. So in the unidirected graph shown the beside is the source vertex that is starting from zero. We have to do the BFS transversal. So to understand BFS, we need to understand that what is the pre-order and level order transversal. So are in a tree. So consider the tree which is given below here. So for the pre-order transversal of a tree, we have to transverse the tree in order, node left, right, like that. So this means we have to first go to a node, then its left and right child recursively. What are the types of BFS? Now let us discuss about what are the types of the BFS. There are several types of BFS in which some are I am taking. The let it be like basic BFS. The standard BFS algorithm that visits all the nodes in a graph or the in a tree level by level, exploring all neighbor nodes before moving on to the nodes and the next depth level. So shortest path BFS, next one. A variation of BFS used to find the shortest path from a source node to all the other reachable nodes in a unweighted graph. It keeps track of the distances from source node to each node visited and ensures that the path found it is the shortest or not. It will ensure that. So at the last, multi-source BFS. In this scenario, BFS is started from the multiple sources nodes simultaneously to find their distances or explore the graph from the multiple starting points. Now let us talk about the applications of BFS. So breadth first search. The BFS can be used to solve many problems in graph theory. For example, let us take finding the shortest path. The previous one which I told you between two nodes U and V. Suppose the U and V with path length measured by number of edges. The advantage over the breadth first search. Finding the shortest path it is over. Now the serialization and deserialization of a binary tree versus the serialization in sorted order allows the tree to be reconstructed in an efficient manner. Now let us talk about the advantages of breadth first search. There are many advantages, like I told you before, to for using this BFS. let us consider one by one. The main advantage is that it is very simple to implement and understand. Yes, it is. Uh, it is guaranteed to find that the shortest path from the starting point to the goal point. Now, BFS tends to find paths with fewer steps, like step by step. Other algorithms, such as the depth first search, also. It is the next program with that. Now, let us talk about the disadvantages of the breadth first search. Now, there are, as I told you before, there are many advantages. Now, there are many disadvantages of this. It can be viewed very memory intensive since it needs to keep track of all the nodes in the search tree. Now, the code of the program is in the description link. You can check it out there. Guys, let us see how to run a program now. Uh, Now I'll go to the Chrome or any searching app. You can do whatever. Then here, search online C compiler here. Then after that, go to this. Now, this is our program. Now, at the initial stage, you know how to do this hashtag include stdio and all that. For a structure to represent the node in an adjacent list. After that, a structure to represent the adjacent list in the same manner. This is for the node and this is for the adjacent list. Now we'll check how to represent the graph, the struct node, struct graph and all that. After that, creating a new node in the adjacent list. Same. Uh, you can see here how it is going on there. And after that, don't forget how to don't forget how to close this, the online, the curly braces, all that. Create a graph with the n vertices now. The struct graph and all that, you know how to do that. And for that, you can check in the description um, as a reference now. So return graph and all that. There should be a particular value to be returned. If not, then your program won't be working. Just add to it. After that, adding an edge to the graph. After that, the program adding an edge from the SRC to the destination, from destination to the SRC and all that. Then BFS transversal of the graph starting from the vertex V, creating a queue for the BFS and mark the current node as a visited in the enqueue, and the loop to visit all the vertices in the graph. Then dequeue a vertex from the queue and print it. For printing, it is mandatory to print it. Then dequeued vertex, get all the neighbors of that. Then if the neighbor has not been visited the mark, then how to do it is. It is the particular program for it. Then int main and all that. You can check and you can refer the thing. At last, you should return, as I told you before only, you should return a particular value at the end. Now, let us see if it works or not. Let us run the program now. Yeah, see, you can see here that BFS is starting from the vertex from 0 to 5, 2, 3, 1, 4, 5, like that. It comes like that. So, like this, you can run a program. Now, what is the conclusion? We came to the conclusion. Now, exploration of the graphs. BFS, it is a systematic way to explore a graph or tree. Data structure level by level. It starts from a source node, then and visits all its neighboring nodes before moving on to the next level of nodes. Now, shortest path, as I told you before, when applied to an unweighted graph, the BFS guarantees that it finds the shortest path from the source node to all the other reachable nodes. It is an efficient way to find the shortest path in the graphs. Now, what are the limitations? We didn't talk about it, but we'll talk now. BFS may not be the most efficient solution for a very large and dense graphs, especially if the goal is to be find the shortest path to a single targeted node. Now, overall, at the end, I want to conclude that overall the BFS is a versatile and widely used algorithm for traversing graphs and solving various graphs related problems. Its ability to find the shortest path efficiently and explores nodes level by level makes it a valuable tool in a many computer science applications. Uh, so thank you for watching and do subscribe and all that. Have a fantastic Friday ahead.